Hi everyone, today we're going to be looking at the Arduino Uno temperature and humidity. We will be using the DHT11 sensor to measure temperature and humidity, and a separate thermistor circuit will also be used to measure temperature on an analog input. This will be all done on our Arduino Uno R3 controller on our Super Starter kit. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So exactly what is temperature and humidity? Well, temperature is the measure of any physical system to transfer heat energy to another physical system. And the temperature of a substance is closely related to the average kinetic energy of its modules. This is the measurement of thermal energy present in all matter. And humidity describes the concentration of the water vapor or water molecules in the air. Now, water vapor, this gaseous state of water, is generally invisible to the human eye. And humidity indicates the likelihood for precipitation, dew, or fog to be present. So up on my screen here, what you'll see is that we have our DHT11 sensor, and the DHT digital temperature and humidity sensor is a composite sensor which contains a calibrated digital signal output from the temperature and humidity, and the dedicated digital module collection technology and the temperature and humidity sensing technology are applied to ensure that the product has high reliability and excellent long-term stability. Now, the sensor includes a resistive moisture sensor and an NTP temperature measurement device, and connects with a high-performance microcontroller. Now, what you'll see is that on our specifications for this sensor, on the specifications, our operating voltage is 3.5 volts to 5.5 volts, and our operating current is just 0.3 milliamps, and that's measured and steadily you're about 60 microamps. Now, the output itself is serial communication or serial data, so it only uses one port on your Arduino, and so it will actually communicate to that port through serial communication. Our humidity range is 20 to 90%. And the resolution accuracy that we have is plus and minus 1 degree Celsius and plus and minus 1% for humidity. Now, even though the accuracy is not great on these sensors, it's usually good enough for applications such as HVAC or heating, ventilation, and air conditioning systems, your weather stations, medical equipment for measuring humidity, and home automation systems, just to name a few. Now, if we look back and we'll say, okay, well, what is a thermistor? Now, a thermistor is a thermal resistor. So a resistor that changes its resistance with temperature. So technically, all resistors are thermistors, but their resistance changes slightly with temperature. But the change is unusually very small and difficult to measure with a regular resistor. So thermistors are made so that the resistance changes dramatically with temperature. It can be up to 100 ohms or more per degree of change. Now, there are two types of thermistors. There's a NTC, which is negative temperature coefficient, and a PTC, which is a positive temperature coefficient. In general, you will use the NTC, and we will use that today for measuring temperature measurements. Now, PTCs are often used as resettable fuses. So an increase in temperature increases the resistance, which means that as more current passes through them, they heat up and they reduce that current. And this is used for protecting circuits. So that's what you heard of thermal overloads. That's what it is. Basically a thermistor PTC that actually is acting almost like a fuse in your circuit. So the first thing we'll do is we will take a look at our actual hardware here, and we'll look at the wiring of our circuits that we have. So currently right now, here is my Elegoo R3 Arduino unit, and here is my DHT11 sensor, and here is my thermistor that I have here, and we have that wired with a it's a 10K thermistor, so this is 10K resistor as well wired into it, so you have to have a known resistor. So we have 3 lines actually, or 3 connections on our DHT, and the first one is my signal, which is going into pin number 2. Then we have my positive, which is 5 volts being fed from our Arduino here, and we have our ground, which is our black. Then on my thermistor and my thermistor circuit, what you'll see is I feed one side of the thermistor with plus 5 volts. In the middle part of my thermistor, we have it going to the first analog signal here, A1. And then our opposite side of our resistor, I have feeding to the ground. So that is my circuit. And what we're actually doing is with that thermistor is creating a what they call a voltage divider. So we have a known quantity resistor, and we have one varies with temperature. So we can quickly determine based on our voltage coming through that, and we measure it through our analog, what temperature that thermistor is going to be at. And we do that by using the Steinhart equation, which is located right here. And I won't go into all the little details about that equation, but it is there, so that's how we actually can measure temperature using this, and measure it quite accurately and quickly. So let's take a look now at our program. And so we'll just call that up. And here it is right here. So the first thing we do is we will include the DHT library. And to do that, you go into the sketch, include library, and add zip library. Now you can get this by downloading the information below, or you can grab it from your Elegoo disk when you came with the Super Starter Kit. So once you have that, it just helps do all that communication for us. The library is already written. So once we have that, we define our sensor itself, and then we set up our constant. So we say that it's on pin number 2 is where the information is coming from. Then up here in my defining, what I'm going to define is my thermistor pin, which is going to be my analog value 0, V0. We're going to define some floats, and then what we're going to do is using the, we're going to calculate the Steinhart coefficients for thermistors, and there is an excellent paper on that right here, which tells you how to do it. And there are actually 3 different methods of actually communicating or calculating those coefficients. So once you have those coefficients, we just plug those into our equation here. So that's what we'll need to do the math in order to see this the sensor and calibrate that thermistor. Then what we do is we start our serial communication. And because we are using on our DHT11 a serial communication to that pin number, what we do is we set up a function that will determine after so many seconds the new information that's come. So this section right here is a function which will return the temperature and humidity that has been read on our digital input. Then we start our loop here, and then we use our formula to calculate our thermistor temperature. And down here, if we comment this, we can actually use the calculation for Fahrenheit degrees. Currently right now we are in Celsius only. And then what we do is we just grab the temperature and humidity, and we're printing this out onto our serial port. So we are using the temperature, we're going to display humidity, and then we're going to say thermistor temperature, and then give it a value. So what we can do is we can upload that to our Arduino Uno R3 from our Super Starter Kit. And it'll just take a second here, and we will update that. So it's uploading right now, and our upload's done. We can then start our communication. And it's about every 4 seconds we get a reading. And what you'll see here is we have about 20 degrees on our actual DHT sensor with a humidity of 47%. And our thermistor temperature is 20.67. So you can see that my thermistor is actually closely calibrated, whereas my DHT11 is not as well calibrated. So it'll give, it's in the ballpark, but not exact. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click that bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.